Welcome to STMicroelectronics. I'm Stefan, and I'd like to show you something that's right on the cutting edge of humans and machine interaction. We call our hand Hank, and what makes Hank special is that we can mirror my hand movements in real time using nothing but a camera and edge AI. No gloves, no cloud processing. Let me show you. As I open and close my hand, watch Hank mirror the movements instantly. The system is tracking my hand pose 21 individual landmarks, including all finger joints at 25 frames per second. Different gestures, different poses, Hank recognizes and replicates them all. And here's what's remarkable. All of the processing is happening right here on this microcontroller. Not a high-power processor, not the cloud, a microcontroller. Notice the smooth, natural response? That's because we're using a global shutter image sensor, the VD66GY from our ST BrightSense family. Unlike rolling shutter sensors, every pixel captured light at exactly the same instant, eliminating motion blur even with fast movements. The system tracks continuous motion just as naturally as a static pose. Let me walk you through what makes this possible. The brain of the system is the STM32N6, our newest and most powerful STM32 microcontroller. It features our custom neural art accelerator, delivering 600 GOPS of AI processing power. That's giga operations per second for neural network inference. The eyes are this VD66GY image sensor, a 1.5 megapixel global shutter sensor that we manufacture in our own fab in France. It's specifically designed for motion vision applications where motion blur is unacceptable. Here's the workflow. The VD66GY captures my hand at up to 60 frames per second. The image data streams over MIPI CSI2 to the STM32N6, where our integrated image signal processor enhances the image quality. Then, the neural art accelerator runs our hand detection and pose estimation models, trained using STM32Cube AI to identify my hand and calculate the 3D position of every joint. For those interested in the implementation details, we are running a two-stage pipeline. First, a lightweight object detection network locates the hand in the frame. Then a key point regression network estimates the 21 hand landmarks. Both models are quantized to int8 and optimized specifically for the neural art accelerator's architecture. The whole inference stack consumes less than 500 milliwatts. But vision and AI are only half the story. Once the STM32N6 knows where every joint is, that information passes to an STM32MP257, acting as a soft PLC, handling real-time kinematics and trajectory planning before sending motor commands downstream. The actual movement is driven by our STSPIN900 motor driver series. 6 parallel outputs per channel deliver the torque needed for fast, precise finger motion. And the entire 6-axis actuator system fits in a single 6x6 PCB board containing 16 SD components. You need this level of integration to make a hand like this possible. What you're seeing is a complete ST stack. STM32N6 for vision AI, STM32MP257 for motion intelligence, STSPIN900 for actuation. One supplier, one tool chain, deterministic timing from camera to fingertip, and far less integration headache than a multi-vendor setup. And the hand itself is not a lab prototype. Hank is based on Ruin RYH2 robotic hand, a 6-degree of freedom servo-driven hand designed and manufactured by our partner Ruin as part of their DEX hand portfolio. It's a commercially engineered platform which makes this demo directly relevant to robotic systems. Now, you might be wondering, what is the practical example or application of this? Let me give you 2 scenarios where this technology is already making an impact. One, industrial robotics and manufacturing. Imagine programming a robot simply by showing it what to do. Instead of writing complex code, a line worker demonstrates the assembly process, pick this part, insert it here, tighten the fastener, and the robot learns by watching. This dramatically reduces programming time and makes automation accessible to smaller manufacturers. 2, human-robot collaboration. In environments where robots work alongside people, natural gestures control creates a safer, more intuitive interface. A hand signal can pause the robot, redirect it, or adjust its speed. You don't need a joystick or control panel. What sets this solution apart is integration. Other systems might use separate cameras, AI accelerators, and motor controllers, each from different vendors, each with their own development environment. And the effort to make them all work together, if they work together, adds up. With ST, you get the image sensor, the microcontroller with built-in MPU, and the motor drivers, all from one supplier, all designed to work together, all supported by a single toolchain. And because this is a microcontroller, not a microprocessor, you get real-time deterministic performance, lower power consumption, and simpler thermal management. The demo board, it runs on USB power. Try doing that with a GPU-based solution. We also offer industrial-grade quality. The VD66GY comes with a 10-year longevity commitment. And the STM32N6 is built on a 16-nanometer FinFET process for reliability and performance. Everything you see here is available today. The VD66GY image sensor is in production with evaluation modules and S-boards ready to ship. The STM32N6 Discovery Kit launched last month, and our STM32 Cube AI Studio software is free to download. It automatically converts your TensorFlow, Keras, or Onyx models into optimized code for the STM32N6. We've also published reference designs and application notes for hand tracking, so you are not starting from scratch. The same goes for soft PLC design and, of course, the design of the motor control board within the robotic hand. Our FAEs can work with you to adapt this technology for your specific application, whether that's robotics, gesture-based controls, or something we haven't even imagined yet. Hank here started as a demo at Sensor and Test last year, but the technology behind it is already being deployed in real applications. In fact, ST is using the same vision and AI technology as part of our collaboration with Oversonic Robotics. We are deploying cognitive humanoid robots in our own semiconductor fabs, starting with our facility in Malta. If you like to learn more about implementing edge AI, machine vision, or motor control in your products, scan this QR code for technical resources, or grab me and one of my colleagues after this demo. We'd love to hear about your applications and discuss how ST solutions can help you bring it to life. Thank you for watching, and welcome to the future of human-machine interaction.